Students, this is the help video for the Unit 6 study guide. Taking a look at A. What you have here is use the property of trapezoids to set up an equation to solve for x. Then find all possible segment lengths or angle measures. So taking a look here, the definition of a trapezoid, of course, is that you have two sets of parallel lines. So it's always a good idea to stretch out the parallel lines. Because you have parallel lines, we have corresponding alternate interior, alternate exterior, and consecutive interior angles. This first one, what you note is if you have two equal sides, you have two equal angles. So in this case, the two yellow angles, because it's isosceles, are equal. Also keep in mind that the yellow plus the green equals 180 degrees. And then you work from there. Coming down here, once again, the yellows are congruent because they have two equal sides. Two equal angles. Now, if the yellows are equal and the greens are equal, I can transfer this 13x minus 3 over here. And then, of course, we have a transversal again, or stir stick. So, of course, here we have parallel lines, which means that these two angles have to add up to 180. And then you solve. On the right-hand side, we're no longer dealing with angles, but we're dealing with segments. And we know that since we have midpoints on either side, because of the hatch marks, this is a median. And this is a base, because the bases are parallel, and that means this is also a base. And median. Median equals base plus base over 2. Now you simply circle, plug, chug where things belong. Solve for x, plug it in. The same is true for this one. And then down here, keep in mind, we have an isosceles trapezoid. And remember, of the 3 things that are equal in an isosceles trapezoid, we have 3 things that are equal. If you go back to that quad family tree, and the 3 things were, you had congruent legs, in fact, take a look here, way in the front. Take a look at the quad family tree, right here. These are the 3 things that are equal. You have congruent base angles. That means these angles are congruent and these angles are congruent. That's congruent base angles. There's that one. You have congruent legs, of course, which are the 2 legs. But remember, you have congruent diagonal lengths, which means the length from there to there is the same as the length going this way. So the 2 diagonal lengths are congruent. So here, the diagonal length, TV, is the same as the length of UW. Why? Because the diagonal lengths are congruent in an isosceles trapezoid. Okay, it says, see the regular polygons below. Extend one side of each shape to create a single interior. Trace the dotted lines, and then sweep the one interior angle. Sweep the matching angles next to it. Use exterior angle equals 360 over n to find a single exterior angle, then find the interior angle right next to it. So, taking a look here, we know this is regular, so step 1, we're going to stretch out this side. And what we're finding here are the exterior angles. So I'm going to do all 3 just so it's easy to see. So the 3 exterior angles would be here, then here, then here. So to find that exterior angle, this one's going to be 360 divided by 3. And of course, that gets us 120. And then we sweep our rainbow, and that gets us our interior angle, which of course, if this is regular, is 60, 60, 60. You want to do this for all 6 figures. Then it asks the question, what do you notice about a single interior and a single exterior angle? What do you notice about the relationship of a single exterior angle and a single interior angle? It's asking, what is that relationship? There's a specific relationship there. says, what is the number of sides? So keep in mind what we're looking for here, number of sides. Specifically, in all our equations, we use the variable m in a regular polygon in which the measure of the interior angle is 17 times greater than the matching exterior angle. So in this case, it's one interior angle is 17 times bigger than one exterior angle. That's the relationship that's being expressed here. You're going to be using part of this, and then from the other side, there was a relationship of the interior and the exterior angle. And your goal here, using this process, is to find what is the measure in this particular polygon, and we know it's regular. Your first goal is to find the measure of one exterior angle, the actual degree measure, and then corresponding one interior angle. Once you find the measures of those angles, you're going to put them right here. Exterior angle, interior angle. Then you're going to use this information about the relationship of the exterior and the interior angle, and you're going to solve ultimately for n, which is the number of sides. See the rectangle HIJK. The diagonals H, IK, and JH intersect at point D. So you want to draw those in. IK, HJ, and they intersect at D. Then it says, very importantly, DJK is 4 times as larger as IJD. It's very important that you trace those very accurately. If you get those in the wrong place, it kind of messes everything up. So DJK, trace and sweep. DJK, trace and sweep. And IJD, trace and sweep. And it says right here it's 4 times as large. So we have a 4x and an x relationship. Keep that in mind. Because it's the word rectangle, of course, you have a right angle. You're also given that H to D is 10 centimeters. Using this, find all possible angle measures and then side and segment lengths round to the nearest first decimal place and the angles to the nearest whole degree. One thing you need to watch out for is that you have both isosceles triangles, which means if you have 2 equal sides, you have 2 equal angles. So I'll just hatch mark those for you. Another thing you want to watch out for is the fact that you have a right triangle going on here, larger right triangle. You're going to be using both those concepts to solve for every angle and side length in the diagram. Says in the diagram below, PQRS is a rhombus. You always want to stop the second you're given a piece of information. PQRS is a rhombus. You want to mark everything you know to be true about that PQRS. That's going to be a rhombus. Then you're told that SRJK is an isosceles trapezoid. SRJK is an isosceles trapezoid. And we're told that JKHI is a square. Okay. So the main thing you want to work out here is simply ask yourself, what do I know about a rhombus, an isosceles trapezoid, and a square? And start marking that, just that. So we come here. If this is a rhombus, we're taking a look at the green. Of course, you have all equal sides. You also have corners that are bisected. You also have, of course, a right angle in the middle, all the way around. Okay, all of that is because of the word rhombus. Coming down here, if this is isosceles, you know the blue, you have two equal sides, you have two equal angles, which means this angle and this angle, whatever it is congruent. Then come here to the square. If this is a square, we know that all four sides are congruent. I'm up to triple hatch marks because I've already used 1 and 2. We also know because it's a square is a rhombus, these are cut in half, which means you have yourself a 45, 45, 90, leg, 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 root 2. So get used to just marking everything you know to be true with those single words. Now, it's very important you trace the next two things absolutely accurately. T, P, Q is twice the measure. T, P, Q is twice the measure of T, Q, P. Make sure you trace those accurately. T, P, TPQ, TPQ is twice the measure of TQP. TQ going this way, P. Twice the measure, which means this is a 2x and x relationship. Last, you're given the fact that S to Q, the entire thing, is 24 root 3, which splits up to 12 root 3 and 12 root 3. And you're also told that K to J, right here, that length right there is 14. Knowing this, find everything possible. Find all segment lengths and angle measures in the diagram. says Hot Wheels has been making die-cast models of popular cars for over 50 years. Below is a picture of a 2010 Mustang GT and its corresponding Hot Wheels model. The length of the actual car is 16 feet. The length of the actual car is 16 feet. The model is only 3 inches in length. And what is the scale factor? What is the scale factor used to size down the car to the model? So what is the scale factor? I want you to express that scale factor both as a fraction and as a decimal. Now remember, scale factor, to change in size, you multiply. So we're saying 16 feet times some sort of fraction. To change in size, just multiply, scales down to 3 inches. To change in size, just multiply. This is your scale factor. Now, the only trick to this entire problem is that you're going to have to deal with those units because you're working right now in 2 different units. Get those to the same unit in order to solve for the missing scale factor. Says right here, use n minus 2 times 180 over n to find the measure of one interior angle of the following polygons. So if we have a 24gon, to find a single interior angle, it's a little hard to see, but you can imagine this angle right here. This angle right there. And it's regular because it is, you're told it's regular. So to find this, for the first one, you're going to do 24 minus 2 over times 180 over 24. Now I'm going to show you how to do this without a calculator because you're smart like that. So we're going to reduce this, which of course is 22 times 180 over 24. I know the temptation to grab a calculator is very high, but you can do this without a calculator. We're going to find the largest number possible that goes into both 24 and 180. So I'm going to try 6 to start with. I know 6 goes here 4 times. And I know 6 goes in there 30 times. Look, we can go down even farther. I know 2 goes in there 15 times and 2 goes in there twice. I can take the 2 into the 22 and it's 11. So to get that measure, I can do 11 times 15. And I get my angle right there is 165. Looky there. You're so smart. You can do that without a calculator. Find the measure of all the angles of these regular polygons. Now it asks which will tessellate by itself. We learned that when something tessellates, the corners, the interior angle corners, have to add up to 360 degrees exactly. So you ask what will do a regular tessellation by itself, and then which of the shapes will combine to make a semi-regular tessellation. In this problem, we're given a quadrilateral EFGH. FGHI. That's all you're told. It's a four-sided shape. You need to positively prove it is a parallelogram, but exclude it cannot be a rectangle. So first, let's deal with the positive. What are the 5 qualities that make a parallelogram? That is the OCD. Remember? And the first O was opposite sides are parallel. Then you had opposite sides are congruent. Then we had opposite angles are congruent. Then we had consecutive angles are supplementary. Last but not least, we know that the diagonals bisect each other. Now, you come over here and you ask yourself, how can you show mathematically the opposite sides are parallel? And parallel is a matter of slope. So if I wanted to show that opposite sides were parallel, I would use the slope equation. If I wanted to show that opposite sides were congruent in length, I would use the distance equation. If I wanted to show the diagonals bisect each other, then it would be the midpoint equation, because it would go through the middle. You only have to show one of those 3 to prove it's a parallelogram. Only one of those 3, your choice. Now, you have to ask yourself, if I want to disprove it's a rectangle, there's a couple ways you can do that. One, what's unique to a rectangle is you have right angles in the corners. In other words, the sides are perpendicular. Right angles in the corners, the sides are perpendicular. Another thing that you could do is, we know that the diagonal lengths are congruent. So in this diagram, we would say something like BD would be equal to AC, or the diagonals are congruent in length. Both would be a possibility. Now, if I wanted to show that there were right angle, that's an issue of tilt. So I would use the slope equation. If I want to show the diagonals are equal in length, I would use the distance equation. You only have to do one of those two. So by either disproving that these sides are not perpendicular or by disproving the diagonals are not congruent, I would prove my second premise. You do whatever's math is necessary. Your goal is to do one of those three possibilities for the positive and then one of the two possibility for the negative. And then do your summary that would explain that your math has meaning. Okay, so remember your sentences should have these three components. You have math. What is the math? What is the meaning of the math? And then what I call the punchline. What's your conclusion? Make sure whatever sentences you use that you have all three components. Math, meaning of the math, and your punchline. This page, take all your measurements. When you find distance, please do this in simplified radicals. It should be pretty obvious, the meaning of your math, if you simply take it step by step and you read everything aloud. This page, it's very important that you watch this first before you go to this information. This is called a glide reflection, which includes both a reflection and translation. A very common glide reflection would be footprints. Okay, so footprints look something like this. This is going to be really hard to draw. So footprint, 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 footprint. Okay, it's both a reflection and a translation. So it says right here that you're going to start with this point. Now watch it. This point, these coordinates are double coordinates. So right here, this first coordinate of P, let's get this in the right place, P, that is -8, -8. And then Q is at -6, -4. And then R is at -2, -6. Says we're going to do this. We're going to plot two cycles of a glide reflection. So we're going to take our first one, we're going to reflect over the y-axis and then translate 3 units up. We're reflecting over the y-axis, so we're flipping over the y-axis, and then we're translating 3 units up. And then we get what's called prime P, prime Q, prime R. And remember, here was the instructions. The instructions were reflect over the y-axis and translate 3 units up. That was the instructions. So, to flip over the y, opposite the x. To flip over the y, opposite the x. So step 1, to flip over the y-axis, you opposite the x coordinate. So this is going to be 8, 6, and 2. Then we go 3 units up. That's on the y-axis, and that's going to be plus 3, plus 3, plus 3. So negative 8 plus 3, that's going to be negative 5. Negative 4 plus 3, negative 1. 2, negative 6 plus 3 is going to be negative 2. Now be very careful when you graph this. Notice your units here are double units. Okay, watch. That's 1, that's 2, that's 3, that's 4, 5, 6, 7, 8, 9, 10. So 8, negative 5 looks like this. 8, positive 8, and negative 5. 1, 2, 3, 4, 5. There's our first P prime coordinate. Then we have Q prime, which is 6, negative 1. So 6, negative 1, you're down just a half step because that's a unit, and that's going to be Q prime. And then 2, negative 2 is right here, and that's R prime. Close it up, and you will see that not only have we reflected that triangle, but we've also translated. It's like a footstep.